Good afternoon, everyone. I am Sıddika Mertdinc from Istanbul Technical University Metallurgical and Materials Engineering Department. Today, I will present to you a comparative investigation of the iron boride nanoparticles, mechanochemically synthesized using the different powder mechanisms. Also, we conduct these are studies into the parts of the project. And I start my presentation with just a brief outline about my presentation. I will continue with the objective of our study, and I try to give an information about the iron boride and also mechanochemical synthesis of the boride nanoparticles. And then I will continue with our experimental procedure. Our experimental procedure consists of the mechanochemical synthesis and purification of the desynthesized nanoparticles, and also characterization investigations of these particles at each processing steps. And I will share the characterization results, and I finished my presentation with the characterization result and just a brief discussion. Okay, the objective of our study, the iron boride nanoparticles, mechanochemically synthesized, followed by the selective acid leaching, using the three different powder composition, three different powder mixtures. And the main objective of this study is synthesize the iron boride nanoparticles without any impurities using solid state reaction. And here you can see the information about the iron borides, their density and melting point, and also their crystal structure. They have a tetragonal crystal structures. Because of that, these boride nanoparticles used to abrasion resistance, corrosion resistance, wear resistance, and oxidation resistance. They can use as a reinforcement nanoparticles for the composite structure because of their superior mechanical and chemically stable properties. And then for this project, for this study, we try to synthesize these nanoparticles, these iron boride nanoparticles, using the solid state reactions. The mechanochemical synthesis is one of the solid state reactions. It's based on the cold welding, fracturing, and rewelding of the raw materials, and using the high energy ball mill, the heat occurred and these raw materials transformed to the boride phase, and these boride phase mechanochemically synthesized using the high energy ball mill and solid state reactions into the high energy ball mill environment. At the end of the mechanochemical synthesis, we can produce a very fine powders, and also these powders this powder processing steps continue with the purification to remove the side products of these reactions. And also mechanochemical synthesis, very novel and facile method to synthesize a various type of boride, carbide, or other ceramic nanoparticles. And I continue with our experimental procedures. For this study, we use the SPEX type of high energy ball mills. As you can see from the photos, there are 4 of the SPEX high energy ball mill, and also we can see the inside of this high energy ball mill device. And also mechanochemical synthesis were conducted into the stainless steel milling vials using the stainless steel milling balls. And firstly, 3 different powder batches were prepared to synthesize the iron boride nanoparticles. First one consists of the iron oxide, boron oxide, and magnesium. Second one consists of the iron oxide, boron, and magnesium. The third one, iron, boron oxide, and magnesium. Firstly, we prepared the stoichiometric amount. The powder batches are based using these raw materials. And these powder batches were filled into the milling vials, into the glow box, into the argon atmosphere to inhibit the oxidation of these raw materials. And then milling vials closed into the argon atmosphere using the glow box, and then they transferred to the high energy ball mills, and they works 1020 rotation per minute speed during the milling. And we milled these our powder batches at least different milling times, and then prepared powders taken from the milling vials, and they need to purification, because if you remember that the magnesium oxide is the byproduct of the desynthesized reactions. So magnesium oxide can be removed using the hydrochloric acid leaching. After the mechanochemical synthesis, these powders leached using the hydrochloric acid, 6 molar hydrochloric acid, and they are waiting into the acidic solution, and they centrifugated and decanted to purify the desynthesized powders. And as a characterization investigation, Bruker advanced series X-ray diffractometer used for the characterization investigations of the phase formations during the mechanochemical synthesis and leaching processes. And also scanning electron microscope help us to detect the microstructure of these nanoparticles, and also transmission electron microscope used for these aim, and vibrating sample magnetometer help us to define the magnetic properties of the desynthesized nanoparticles. And these are the XRD pattern of our raw materials: iron oxide, magnesium, boron oxide, and boron nanoparticles. Boron oxide and boron include because of the humidity, they have an additional phase inside it. And also 3 different routes and 3 different powder batches were prepared, and then they filled into the milling vials, as we mentioned before, these 3 different powder mixtures. And firstly, the first batch, iron oxide, boron oxide, and magnesium batch, as blended powders, XRD pattern were clearly seen from the left-hand side, and our initial materials, the peaks belongs to these materials, were clearly seen at this XRD pattern. After the 4 hours, 6 hour, and 8 hour milling, these XRD peaks belongs to the raw materials were completely removed, and iron boride and magnesium oxide peaks were clearly seen after the milling. And also the second batch consisted of the iron oxide, boron, and magnesium. The similar XRD patterns were clearly seen here. The first, as blended powders, consist of just our initial raw materials. After the milling with various durations, iron boride and magnesium oxide peaks were clearly seen, and also it shows us that the iron boride synthesis were successfully conducted after the mechanochemical synthesis. But still we have a magnesium oxide peaks. Also we will leach it to remove the magnesium oxide phase to our nanoparticles. And the last one is the iron, boron oxide, and magnesium batch. Again, we can see the as blended and milled for the various durations powders XRD patterns. Also here we see that our main peaks belongs to the iron. And the last one, the last XRD pattern show us that these 3 different, using the 3 different routes, after the purification, we can eliminate the magnesium oxide peak to our XRD pattern, and we have just only iron boride peaks, and this shows us the purified our nanoparticles. And these are the XRD SEM images of the synthesized nanoparticles belongs to the first batch. They looks like a nano sized and irregular shaped, also like a spherical shaped nanoparticles after the leaching. We have this type of particles. Also, elemental mapping results shows us that the magnesium and oxygen located at the same areas, and it shows us the magnesium oxide formations. And also these are the transmission electron microscope images, and also still after the leaching, we can see the iron and boron phases at the elemental mapping structures were located at the same place, and there is no other elements. So the pure iron borate phases were synthesized. Also, we can see the irregular shaped nanoparticles in detail, the transmission electron microscope image. Also, this transmission electron microscope image belongs to our second batch, second raw material batch. Also, again, we can see the iron and boron locations, but the irons were really high intensely distributed into the structure. The boron, just a few points detected using the boron, but this spacing again shows us the iron diiron boride synthesis. And this is the last one, and again we can see the iron borate synthesized using that, and but we can see the irregular shaped nanoparticles based on the transmission electron microscope image. And these are the VSM vibrating sample magnetometer results of these synthesized and purified nanoparticles. Also, you can see the both magnetic hysteresis loops belongs to these three different powders, and also the image near to the magnet, the particles go through to the magnet, and also it shows the magnetic properties of these materials. And in conclusion, iron boride powders were mechanochemically synthesized for different duration from the different powder batches, and then also they purified using the hydrochloric acid treatment to remove the magnesium oxide in our laboratory facilities. All synthesized powders exhibit the soft magnetic behaviors compared with the literature values based on the magnetic hysteresis curves taken from the VSM results. Also, the saturation magnetization and magnetic remnant and coercivity, low remnant magnetization and coercivity exhibit the soft magnetic properties of these synthesized nanoparticles. And thank you for attention. Also, thank you to organization committee to organize this conference. And also, I want to talk about this study was supported by the Scientific Technology and Research Council of Turkey. And if you have any questions, please. Thank you.